Hey, and here we are. We're going to start talking about inverse sine and cosine today. And you may be going, whoa, what's an inverse? I don't remember those things. Well, I'm glad you asked because here we go. Here's what an inverse function really is. Okay. Oh, here's our vocabulary. We're going to talk about, actually, before we get there, we're going to talk about arcsines today, arccosine, arctangent. These are all the inverse functions. The inverse function of sine is arcsine. The inverse function of cosine is arccosine. And the inverse function of tangent is arctangent. But again, what are these things? These inverse functions. Here's the straight math definition of it. Okay. The way we say this is if I were to take a composition of functions, f inverse of f of x, I would get x for every x in the domain of f. And conversely, I would also have, if I took the f of f inverse of x would equal x for every x in the domain of f inverse. What's all that? Okay. Basically what it's saying is that I can take the x's and the y's. You know, if I had a function where y equals x, I switch the x's and y's around. There we go. That's an inverse function. And what that means is, if you're told that a function is the inverse function, here's the big key points you need to know. Is the domain of my first function is now the range of my inverse function. And the range of my original function is now the domain of my inverse function. Okay? So other things that I need to know is that the graph of my original function and the graph of my inverse function are symmetric with respect to the line y equals x. And finally, if a function, or my original function has an inverse function, the equation of the inverse function is x equals f of y. And the solution of the equation is y equals f inverse of x. This is what we, this is not f to the negative first power. We say it's f inverse. Great. Now that you have a little reminder of what an inverse function is, again from Algebra 2, how does that supply to the sine function? Well, here's our sine function. All right, we started talking about, here's my sine function, right? It starts here at 0, 0, goes right up and down. It keeps going forever. Okay, the problem is if I wanted to create my inverse function, and I do want to create an inverse function, so here I go. My x's and y's switch. That means everything I see on my x-axis here would now become my y-axis. So all of this would be, negative pi. Negative pi over 2. Pi over 2. Pi. And it keeps going. And this here would be 1 and negative 1. Oh, okay. So then all I do is tilt my head on the side, and I would graph my function. And so it would start here and go. Let's see, we get a lighter color so it shows up better. There we go. So start here, and it'd be something like this. The problem is that in itself is not an inverse function. Why? Well, because this is not a function, because when I do my vertical line test, I hit values multiple times. I can't have that if I want to talk about a function. So what ends up happening is the math powers that be said, hey, I want to restrict my domain of sine to where I get every value in my range, and that's it. I don't want my range more than once. And you can tell on the slideshow here, but you probably can't tell in your notes. This is the one that they chose. So I'm going to highlight this. They chose here from negative pi over 2 to pi over 2. They restricted the domain. That's the only part that we're going to worry about for looking at it for my inverse. And so my actual inverse function is here. That's the inverse function. Why is this important? Because you're going to be expected to be able to know the values at certain points. And so what does that mean for you? That means that you have to go back to your unit circle. Oh gosh. And if they're talking about here from negative pi over 2 to pi over 2 being my restricted domain, what does that mean for you? That means that for inverse sine, this is my domain area. This is for inverse sine. That's my domain. Okay. Or my range, excuse me, and my domain. That's where inverse sine lives, in those two quadrants. So you're going, great. So what? Well, again, glad you asked. Okay, so here's the formal definition of things that you need to know. You need to know what inverse sine looks like. You need to know that its domain is from negative 1 to 1. You need to know that its range is from negative pi over 2 to pi over 2. And that's the entire function. There's nothing more than that. That's it. There's nothing higher. It doesn't go on forever. There's nothing lower. It doesn't go on forever. There's nothing to the right. There's nothing to the left. This right here is my entire function. Okay? So the other things that you need to know is symbol-wise. Okay? Is that y equals inverse sine of x. That's how we can say it. That's inverse sine. The other way that we say it, we can also say that y is equal to arc sine of x. That also means inverse sine. Okay. So again, you know, I have all this notation. I have an idea now of what the graph looks like, but what does it actually mean for a math problem? Well, what it means is it says, find the exact values of sine inverse of 1. So what I have down here, down below, is a table of theta and sine. Notice it's not sine inverse. Well, great. What does that mean? Well, with the sine function, it took a degree measure or a radian measure and output a ratio. Inverse sine does the opposite. Inverse sine, okay, sine inverse of x takes in a ratio, and its output is an angle measure. Okay, so again, so now if I look at this, find the exact value of sine inverse of 1. So I have to think about where is sine equal to 1 on negative pi over 2 to pi over 2. And yes, this is something that you should probably start memorizing again. Okay, get back in the swing of things. It's been a long 2 weeks. So though I've helped you out here. So what this means is that in this example, this here, even though it's theta, this is now going to become my output, and this is my input. So if I want sine inverse of 1, so now I can say that this is x. Oops, better color. You can say that this is x, and this is also sine inverse of x. So x in this case is 1. Where is it equal to 1? Over here. So sine inverse of 1 is equal to pi over 2. Dink, dink. So use that same thing for another one. Another example. So it says here, find the exact value of sine inverse of 1 of negative 1/2. So again, I take a look at where is sine negative 1/2. Sine is negative 1/2. Oh, let's see. No. Oh, wait. There it was. right here. Sine is negative 1/2 at negative pi over 6 equals negative pi over 6. All right. Next one I want you to do is for you. Okay. So this says find the exact value of arc sine of negative square root of 3 over 2. Again, arc sine is the same thing as sine inverse of sine. So this is where you pause me and you go and find the exact value for that. Okay. Pause me, pause me, pause me. Boom. There's your answer. All right. Let's go ahead and find out what's next. So here we are, inverse cosine function. This one I'm going to go a little bit quicker with. Okay. So again, the math people were like, hey, I can't have, again, I have the same problem I have with sine. If I just switch the x's and y's, it's not going to make a function. So where am I going to restrict my domain of cosine so that I hit every y value of cosine? And so what they decided was that I'm going to restrict my cosine domain to from 0 to pi. All right. And so what does that mean for here? That means over here on your unit circle, from 0 to pi, it only arc sine only covers those two quadrants. So again, you need to put those in your memory bank. All right, you have to memorize more. I know, it's scary. So again, let's take a look at, now let's go ahead and take a look at what does this arc sine function look like. So it's the angle between 0 and pi with the cosine of x is what that means when you see inverse of cosine. There's my symbols. Also, don't forget that this can also be y is equal to arc cosine of x. If you see that, it means the same thing as inverse cosine. And this is what the graph looks like. Again, you need to know what this graph looks like. Be able to say, yes, that's the inverse cosine graph. Okay? Just like you can say, hey, that's a x squared graph. And again, that's the entire graph. It goes from 0 to pi for its range. It goes from negative 1 to 1 for its domain. Same domain as inverse sine. That's it. All right. So next, how do I use these in problems? Again, glad you asked. So again, here, find the exact value of inverse cosine of 0. This time I have a vertical graph, but let's go ahead and say inverse cosine. So again, I find out, hey, let's see here. So this right here is really going to be my answer. This is my inverse cosine of x. And this here will be like my x. So it's saying 0, so I go and find 0 on here. And my answer is pi over 2. So I go ahead and write this out. I say inverse cosine is equal to pi over 2. I'm going to give you guys the next two on your own. Find the exact value of this one on your own. Okay, pause me right now. Bada bing, there's that answer. Should be self-explanatory at this point. You've seen several examples that use this. And one more for you to go ahead and pause me for. Find the exact values of -1, inverse of -2. Again, there's your chart if it exists. All right, so I go ahead, okay, pause me, pause me, pause me. Oh, tricky I am. Cosine inverse of -2. Look, again, you need to make sure that you understand that this here is my x part. This is my inverse cosine part because I'm switching my x's and y's for cosine, right? So -2, do I see a -2? No. Why? Because my range, or my domain, for inverse cosine is just from -1 to 1. You need to know that. It cannot go beyond that. Okay? So if I ask for -2, It's not there. All right. So what's next is, well, how can I use these to solve equations? Oh, gosh. So here I have this equation, 2 cosine inverse of x equals pi over 2. Well, again, when we solve stuff like this, what I like to do is treat this inverse cosine part, treat this piece as a big giant unknown. I'm going to call it u. So if I treat it like that, I can say, well, hey, 2u is equal to pi over 2. I can solve that. I divide both sides by 2. U is equal to pi over 4. But that's not what u is. Okay, it's cosine of u. Oh, so inverse, so here we are. Inverse cosine of x is equal to pi over 4. So how do I technically solve that? Well, to undo inverse cosine, how do I undo an inverse? I take the original, I take cosine of both sides. And when I take cosine of both sides, this part goes away and just becomes x is equal to cosine of pi over 4. And at this point, you should not have to go and cheat, hopefully, and say x is equal to square root of 2 over 2. And that's my answer. Okay. Hopefully that helps you out. That one. So now I gotta be able to use this in a problem. So here we go. Alright, so it says in a movie theater, a 32-foot tall screen is located 8 feet above the ground. Write a function modeling the viewing angle for this person in theater whose eye level is set 6 feet above the ground. So the problem's kind of written badly again because it doesn't show you what you're actually looking for. It says they're asking for theta is the viewing angle. What's the viewing angle? Is this dashed angle here. This is theta. So what this really means is the theta that I'm looking for is equal to the whole big theta sub 2 minus theta sub 1. And that's what they want me to find. They want me to find out that theta. All right. Well, great. I found an equation for it. Woohoo! But it doesn't tell me a lot. I mean, I still don't know how to find theta 2 or theta 1. And there's a way to do it. You can see that you have this. Well, first let's figure this out. What's this distance right here? This itty bitty distance. So here I am 6 feet. That's a big person to be sitting down there and be 6 feet tall when they're sitting. It's huge, right? Okay, so they come over here, 6 feet tall. So that means this little itty bitty section is just 2 feet. And now we have to go back to geometry class. Oh God, not geometry. All right, and we wanted to go back to actually, what we started before the break, which is that SOHCAHTOA business. I want to find this theta 2. I have this right triangle here. Okay. And I have, this is some d. And this is some distance that's 34 now with this theta. I have to remember, oh, hey, yeah, opposite over adjacent, TOA, tangent. So I can write this out. I can write out that tangent of theta 2 is equal to opposite over adjacent. Similarly, I got the skinny right triangle right over here, where I can say that tangent of theta 1 is equal to 2 over d. Great. Well, how does that help me out? Well, this is where inverse tangent comes into play. Okay, or inverse sine or inverse cosine, depending on the ratio I set up. In this case, it's tangent. And in this case, I'd be able to say, you know what? How do I undo tangent? Because I want theta 2 all by itself so I can replace it in there. How do I undo tangent? I do inverse of tangent to both sides. If I do inverse of tangent to both sides, inverse of tangent to, of tangent goes away, and all you get is theta of 2. Inverse tangent of 34 over d. Similarly, I can then say that theta 1 is equal to inverse tangent of 2 over d. And now I have an equation to where I can find theta precisely as long as I know the distance. And that theta is going to be equal to inverse tangent of 34 over d minus inverse tangent of 2 over d. And if your mind is completely blown, congratulations. Okay, the most that I'm going to ask you guys to do is what's given here. I'm going to ask you guys to be able to come up with the equation. You need to be able to understand the steps, and you need to be able to ask me questions maybe tomorrow about why you don't understand if you don't understand. Okay? All right, that's about it. Hope to see you guys tomorrow, and we'll talk to you guys soon. Bye.